Pythagoras theorem, and trigonometry. The theorem is named after a great mathematician from Greece known as Pythagoras, who lived about 580 to 500 BC. As a philosopher and a mathematician, Pythagoras learned many facts about mathematics from Egyptians, where he used to travel a lot. One fact that caught his attention was the right-angled triangle with dimensions 3, 4, 5. It was known that 3 squared plus 4 squared is equal to 5 squared. However, it was Pythagoras who discovered that this convention is general for all right-angled triangles, hence the Pythagoras theorem, which states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the shorter sides. This is illustrated below. H squared is equal to A squared plus B squared. This theorem is applied in finding the unknown sides of a right-angled triangle. For example, find the length of the side marked x in the triangle below. In our solution, x squared plus 5 squared is equal to 13 squared and x squared is 144, x is 12 centimeters. Example 2. A ladder measuring 25 centimeters is to be leaned onto a wall. How far from the wall should it be placed so as to reach a height of 24 meters? This information can be represented as below. D squared plus 24 squared is equal to 25 squared. D squared is 49. D is 7 meters. Trigonometry. The word trigonometry is borrowed from two words, trigono, meaning triangle, and metron, meaning measurements. Trigonometry is the study of relationships of angles and measurements of triangles. The Greek letters alpha, theta, beta, gamma, delta are used to indicate or denote angles. We've seen how sides of right-angled triangle are related by the Pythagoras theorem. Here we study the relationship of acute angles and the sides of right-angled triangles. With reference to angle theta in the figure below, the sides of a right-angled triangle are named as follows. Trigonometric ratios. The three trigonometric ratios are sine, cosine, and tangent. Conventionally, the relationship between these ratios and the sides of right-angled triangle are as follows. For an acute angle theta, tan theta is opposite over adjacent. Sin theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. For example, find the length of the side marked X and Z. In our solution, sin 30 is equal to x over 20. This is because x, 20 centimeters, and 30 degrees are related by sine. Therefore, x is equal to 20 sine 30, giving us 10. Z, 20 centimeters, and angle 30 are related by cosine. Cos 30 is z over 20, and z is 17.32 centimeters. Degrees and minutes. 1 degree is divided into 60 equal parts called minutes. 1 degree is equal to 60 minutes. Therefore, 0.5 degrees is equal to 30 minutes. 0.2 degrees is equal to 12 minutes. 300 minutes is equal to 5 degrees. Trigonometric tables. Special tables have been prepared for finding the ratios of angles from 0 to 90 degrees. Tangents of angles decrease as the angle decreases. The signs increase from 0 to 1 for angles from 0 to 90 degrees. The cosines decrease from 1 to 0 for angles from 0 to 90 degrees. Sines and cosines of complementary angles. Consider sine 30 is equal to 0.5, cos 60 is equal to 0.5, sine 60 is 0.866, cos 30 is 0.866 also. "60 degrees and 30 degrees are complementary angles, that is, they sum to 90 degrees. Similarly, 65 degrees is complementary to 25 degrees. Generally, for two complementary angles alpha and beta, sine alpha is equal to cos beta. For example, sine 30 is equal to cos 60. Cos 30 is equal to sine 60. Sine 25 is equal to cos 65, and so on. Thus, for an angle theta, sine theta is equal to cos 90 minus theta. For example, solve the following. Sin x is equal to cos 72. B. Cos x is equal to sin 5x. In our solutions, A. Sin x is equal to cos 72. X and 72 are complementary. Therefore, x plus 72 is 90 and x is 18 degrees. B. Cos x is equal to sin 5x. X and 5x are complementary. Therefore, x plus 5x is equal to 90 and x is 15 degrees. Relationship between sines, cosines, and tangents. Consider the triangle below. Sin theta is equal to A over C. Cos theta is equal to B over C. And tan theta is A over B. Now, sin theta over cos theta is equal to A over C divided by B over C. And we cross multiply and we shall end up with A over B. But A over B is tan theta. Therefore, sin theta over cos theta is tan theta. For example, given sin theta is 3 over 5 and cos theta is 4 over 5, find tan theta. In our solution, sin theta over cos theta is equal to tan theta. Therefore, 3 over 5 divided by 4 over 5 is equal to 3 over 5 times 5 over 4, which is 3 over 4. Trigonometric ratios of special angles. Consider a right-angled triangle which is also an isosceles triangle. The acute angles are both 45 degrees. From Pythagoras' theorem, PR squared is equal to x squared plus x squared, which is 2x squared. PR is square root of 2x squared, which is x root 2. Tan 45 is equal to PQ over QR, which is equal to x over x, which is equal to 1. Sin 45 is PQ over PR, which is equal to x over x root 2 and is equal to 1 over root 2. Cos 45 is QR over PR, which is x over x root 2, which is 1 over root 2. Hence, tan 45 is equal to 1. Sin 45 is 1 over root 2. Cos 45 is 1 over root 2. We can see that 45 degrees and 45 degrees are complementary, and that is why their sine and cosines are equal. Now consider an equilateral triangle below. PS squared is equal to PR squared minus RS squared. That is 2 squared minus 1, which is 3. PS is equal to root 3. Tan 60 degrees is equal to root 3 over 1, which is root 3. Sin 60 is root 3 over 2. Cos 60 is 1 over 2. Tan 30 is equal to 1 over root 3. Sin 30 is equal to a half. Cos 30 is root 3 over 2. Note that tan 0 is equal to 0. Tan 90 is undefined. Cos 90 is equal to sin 0 and is equal to 0. Sin 90 is equal to cos 0 and is equal to 1. Application of trigonometry. An example: the sun hits the top of a pole 15 meters high at an angle of depression of 25 degrees. It casts a shadow on the opposite side. Calculate the length of the shadow so cast. In our solution, we can sketch the figure as below. The angle of depression is equal to the angle of elevation. Therefore, tan 25 degrees is equal to 15 over s, and s is equal to 15 over tan 45 and is equal to 32.17 meters.
At Philadelphia University, to study the effects of poaching, biology student Kendra Talbot didn't hang out in class. She hung out here, in Kenya, conducting research that explored the delicate balance between human and wildlife survival. To change the world, you have to be in it. At least that's our philosophy. Check out Kendra's and other Power to Do stories on our website.